Mr. Duke, what happened to lesson 4? I skipped it. I decided that this morning. So it's going to go lesson 1, 2, 3, 5. Often when we're completing a lab or an activity, we would like to know the accuracy or the validity of our results. And if we have a correct or a known value that was derived with better equipment than the lousy stuff that I have, to compare our lab results to, we can find out our error and our percentage error. And we will often do this at the end of an activity where we know what the value theoretically should be, and then we'll say, but this is what we ended up with. How close are we? Error is defined as the theoretical or calculated value, what your lab discovered, what you measured, minus the known or accepted value, what you know is correct. Except you take the absolute value of that. That's what these vertical bars mean. Do you see absolute value in Math 10? Have you been introduced to that? Those of you in Math 10, have you seen those vertical bars? No one's nodding or shaking their head. That doesn't help me at all. Have you seen those vertical bars around a number? Have you heard the term absolute value? If you haven't, please shake your head and then I know. Thank you. That's how it works, Justin. Put your pencils down, look up. Absolute value is a mathematical expression that asks, how far are you from 0? It's symbolized by 2 vertical bars, and you would read that as the absolute value of 5. And it turns out the absolute value of 5 is 5. Because how far are you from 0? 5 away. The absolute value of negative 5 is 5. Because how far are you from 0? Even if you're in the negative direction, you're still 5 away from 0. What's the absolute value of 7, boys and girls? What's the absolute value of negative 7, boys and girls?
7.
What's the absolute value of 19.3, boys and girls? 19.3. What's the absolute value of negative 19.3, boys and girls?
19.3.
Okay, so if you want to remember it, Ethan, as, oh, you just chuck the negative, that's how you're getting the answer. But if you're wondering why it's defined that way, there are times when you get a negative answer based on the order that you put the numbers in, but you don't care about the negative part. In particular, when we're doing error, if you get a negative answer here, make it positive. Or always get in the habit of going bigger minus smaller, and that will guarantee you get a positive answer. So even though I said it's the theoretical or calculated value minus the known or accepted value, sometimes, Hannah, if this number is bigger, I'll go this minus that. It's going to give me the same answer and just check the negative for me. Some of you now just realized, oh, Mr. Dewick, is that what that ABS button on my calculator is for? Yes, it is, boys and girls. That's the absolute value button. So, absolute value just means make your answer positive even if it's negative. So in other words, if you want it to be positive in the first place, you can always get in the habit of going the bigger number minus the smaller number. I'll probably do that, Morgan, without even thinking about it. Habit. Okay? We're going to come back to percentage error in a second, but we're going to go to example 1. Suppose a police officer uses a radar gun to clock a passing Ferrari at 211 kilometers per hour. But the Ferrari was really speeding at 199 kilometers per hour. Calculate the error. So the measured value, the value that is not correct, but it's what we have to deal with, is which one of those two? Let's write a little 211 there. The value that we know is correct, the known value, is equal to what? 199. That's a terrible 9. 199. So the error is going to be bigger minus smaller. I'll go 211 minus 199. If it was the other way around, I'd just go the other way around. Now, you can put the absolute value bars there if you really want to feel like a nerd, because that's how I kind of included it on your formula sheet handout. Fine. But that's what we're going to do. Which is what? 12, I think, yes? We would say the error in this radar gun is 12 kilometers per hour. That doesn't tell us very much. We like to convert this to a percentage error, because if you're accurate to within 1%, that's better than if you're accurate to within 90%. That means you're way off. If you're accurate to within 1%, you almost got bang on. If you're off by 18%, you were way off. So how do we do that? Scroll back up here. Percentage error is the error, which you figured out by going bigger minus smaller, divided by the answer that you know is correct, the known or accepted value. That will give you a decimal. To turn a decimal into a percent, you multiply by 100%. So the percentage error for this radar gun, we would say this. My symbol for percentage error is the percent symbol and then error. That's going to be the numerical error divided by which of those is the correct known value. 211 or 199? 199, and then multiply it by 100 to get a percent. What do you get? Oh, and let's go for percentages maybe to 1 decimal place. Oh, well, really, how many sig figs?
2.
How many sig figs?
30.
Are we multiplying and dividing? I should go to 2 sig figs. Let's go to 2 sig figs. Get 6.0. Which might be enough to get that ticket tossed in a court of law. I don't know what their standard of accuracy is for a reasonable doubt to occur. I don't know how accurate a radar gun has to be. I made these numbers up, Chantel, but certainly this would be an approach if you were trying to dispute a radar gun ticket. If you had some data, you might be able to use this to say, look, you're off by 8% with these 8 people. There's a strong likelihood that you're off by 8% with me, and that 8% is enough to put me below the speed limit. Example 2. 2 people, wow, I was making up weird names, Reginald and Dagmar, measure their weight in the morning by using typical bathroom scales. And you should know this. Bathroom scales are famously very, very unreliable. The scale reports that Reginald weighs 237 pounds, although he actually weighs 256 pounds. Dagmar's scale reports her weight is 117 pounds, even though she really weighs 129 pounds. Whose measurement incurred the greater error? I think this is a kind of a two-parter. We're going to figure out the error for Reginald. We're going to figure out the error for Dagmar. Whenever there's a two-parter, I tend to just draw a little line down the middle of the page. I like to be maximum organized for minimum work. Let's do Reginald first. Capital R underlined. There. I think later on when I look at this, I'll figure out that that's Reginald. Louisa, you already did it? Yeah. What did you go? What minus what?
I did 256 minus 256.
In our notes, we'll write this out so that when you're studying later on, you know what the heck we did. Honestly, if you do this on a lab, you would write it out, I guess, as well to show me your numbers. In your homework, if you want to do it quick on your calculator, go ahead. But you went 256 minus 237. How much error is there in Reginald's scale? 256 minus 2, 19? Compare that with Dagmar. The error in Dagmar's scale is going to be 129 minus 117, which is 12? We haven't actually answered the question. The question asked which measurement has the greater error. Which measurement has the greater error? Reginald. What do 3 dots mean? You know what 3 dots mean as an abbreviation? So I'm going to teach you to abbreviate. Okay? Therefore, or in conclusion, or as a result, or we can now say so. Because this is not the answer, and this is not the answer, but because of those 2 numbers, who has the greatest error? Therefore, maximum clarity for minimum writing. Right? By the way, we always have a saying in math or in physics or in science, whenever you see a therefore, make sure you know what it's there for. What we're really saying is that's an important symbol that usually means several steps have gone to arriving at a conclusion. Make sure you can follow the steps. Who's incurred a greater percentage error? Okay, let's do the same thing. I'll just change colors. I'll go to black. There's Reginald. So, percent error is going to be the error, which was 19, divided by the correct value. What was the correct value for the scale? For the mass? 256 was? Yeah? Or is it 237? 256 was the correct one?
256.
Okay, the actual value. And then times 100%. $19 divided by 256, and then times 100. And I get 7.4. I think I'd go to 2 sig figs because of the 19. 7.4%. Let's compare Dagmar's, which is going to be 12 divided by, what was her actual value? 129? Oh, you know what? I wrote kilograms. It's pounds, isn't it? Abbreviation for pounds is LBS. You know what? That's a stupid abbreviation. I'm going to use the pound sign. And then I should multiply this by 100 to get it as a percentage. And I get 9.3? Yes? So who had the greater error? Reginald. Whose scale was off by a bigger percentage? In other words, which scale is less accurate? Probably Dagmar's, because it was off by a bigger percentage. Even though it wasn't off by as much in kilograms, it was further as a percentage from the correct answer than Reginald's was from the correct answer. Therefore, Dagmar has greater percent error. Mr. Duick estimates that it will cost him $7,650 to rebuild his porch. The actual cost is $9,800. Calculate the error. $2,150. Yeah. Calculate the percentage error. Now, let's suppose that we were bidding on a bridge and the bridge was like $150 million. If you were off by that much, your percentage error would be really small. You'd be almost bang on. As compared to on this deck, this is why percentage error tells us more than actual error. You need to know, well, what was I comparing it to? How close was I as a percentage? So, percentage error 2,150 divided by the value that I know is correct, 9,800 times 100%. And I get 21, you know what, to 2 sig figs, because I think each of, well, yeah, 3 sig figs, 2 sig figs, 2 sig figs. I think I'll go 22%. Not terribly good. Not hideous, but not great. Is that okay? I'm going to get us ready for a lab. Take about 5 minutes or so right now while I'm getting ready. You can work on the take-home quiz. I did say I'd try and give you some time in class. Yeah.